2005, I started making some sand cars on the side. Made a total of 5. Then '08 happened and all that went away. Had the idea of getting back into doing something like that, but the sand car market was really niche. Side-by-side market was heavily saturated. So I started doodling. I like the C2 Corvette, it's one of my favorite cars. And I thought, heck, let's make a car, a C2 Corvette, out of tubing, and let's see what happens. So located at 2009 Z06, this was running and driving and complete. It was hit on the B-pillar side right at the door latch, so the insurance company totaled it. The dealer I bought it from basically stripped it down to all the parts that I didn't need, which made it great. Did some CAD work, actually CAM work, computer-aided measuring, to create a digital file, which is the CAD file for the frame, its mounting points, its suspension points, located and scanned a 66 Corvette, which is here, and put those two files together to create a 3D model. We have the outer frame rails. We lined that up with one of the scans that we did to make sure everything's fitting. Converted that CAD file to tubing. Of course, made some minor tweaks here and there, which then gives us a complete working 3D file. Did some research on some hydraulic benders. So located one, get that ordered, all of our steel, and then we started bending. So the first bend was also the hardest, of course. It's about a 16-foot stick, has 6 bends with 5 offsets. Did a dry fit real quick, and then finished out, completed the outer frame. Started on the inner frame to create the torque tunnel, or the torque tube tunnel. And then once that was completed, we set it down on the powertrain. Mounted up the A-arms, and of course we had to install the tires and wheels. This came out amazing. Of course, we were geeking on it. Did a quick fit, make sure we got enough foot space. Got a nod there from Jason. So the next thing we needed to identify was the location of the sump pump. We're basically going to keep it in the same spot as the OEM, and that was the determination. This is the mock-up we did for the wheel well. It's based off the tire and wheel mounted. Try to get his fitment as close as we can, but I later learned that these were too short and too close, and they had to get cut back out. You have to mark the piece, so I find center to bend my way out. You identify the start of the bend and the termination of the bend. And if there's a lot little ones, put it on the radius bender and work out from there. First B-pillar piece you see there on the framing table, that was actually incorrect size, though the width on the bottom was correct. The width on top was too narrow, was actually incorrect. So that piece ends up in the scrap pile. This process has not only been measured twice, cut once, but it's really a measure 2, 3, 4 times to bend once. It is definitely a learning curve. Using this hydraulic bender, I learned rather quickly, since I'd never really used one this extensive before, you can really bend or try and bend into the degree that you need. If you go past it, then that piece is scrapped and you have to start over because you really can't change the correction of that bend. So you have to kind of walk into it or get close to the bend, take a measurement, and then notch it in, or knock it in, as they say, to get the bend that you need. So this looks repetitious here, which it somewhat is, but I'm dialing it in to get the accurate measurements that I need. I use a tool to do all my notching, or at least most of the notching. So what you see here is I'm just incorporating the ladder to help support the size of the piece so I can make the notch. So I designed this with two B pillars somewhat kind of mirror from each other, though they are different. The forward one is taller and wider, and the rearward one is slightly smaller to kind of give the accent of the back end swooping in. So though they look similar, they are very different.